All right, so trig identities for this week. This is section 7.2, angle difference formula. Cosine of the difference of two angles, alpha minus beta, is cosine of alpha times cosine of beta plus sine of alpha cosine of beta. It's a similar one for the sine. Sine of the difference of two angles, alpha minus beta, is the sine of alpha cosine of beta minus cosine of alpha sine of beta. And a couple things to think about here to try and get these straight. Cosine, we're going to come back to this one. This, I think, is one of the more important ones right there. The angle difference is cosine, cosine, sine, sine. The sine doesn't quite do that. It does sine, cosine, cosine, sine. And notice that the difference in the angles is the difference in the trig functions. So one thing that helps me remember this again is the cosine is always cosine, cosine to start with. And the sine switches and gets the signs right. So sine gets signs right. Right, so notice the difference in angles is a difference in trig functions. Doesn't happen for the cosine up here. Related to that are the angle sum formulas. So if we take cosine of alpha plus beta, that's going to give us cosine of alpha, cosine of beta, minus sine alpha. Let's see. Oh shit, I have an error in my formula up above. Sine beta. Should be cosine, cosine, sine, sine up here. Eraser. So that right there should be a sine. Cosine, 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 sine, sine. Cosine, sine, cosine, cosine, sine. Yep, there we go. That's the right way. And then similar for the sine of the sum of two angles, alpha plus beta, starts off the same way. It's going to be sine of alpha, cosine of beta, plus, because the sine gets the signs right, cosine alpha, sine beta. Right? And notice for the sine, when we get to the second one, we switch the order of the trig function. So here sine had alpha, and now over on this other side, sine has beta, right? So things have to get mixed up there a little bit. So those are the angle sum and angle difference formulas, and they're going to allow us to find some other special angle values that we'll see in a little bit. Next set of important formulas are it's kind of like it's a wave sum shift function related to these here. So wave shift. And the way this one works is we have some amplitude times the sine of bx plus c. And because of the formulas above, that can be rewritten into the sum of a sine and a cosine. So some number m times the sine of bx, same period, plus some number n times the cosine of bx. And often this is used the other way. If we have a sine and a cosine with the same period being added or subtracted, that can be rewritten as a single sine function with a shift instead. So we'll take a look at that in a little bit. Then we have the product to sum and sum to product formulas. And I'll justify a few of these, and mostly we'll just use them. So if I have the sine of alpha times the cosine of beta that is equal to 1/2 sine of alpha plus beta plus 1/2 sine of alpha minus beta. If we had the sine of alpha times the sine of beta, that would be 1/2 cosine alpha minus beta minus 1/2 cosine of alpha plus beta. And then cosine of alpha, cosine of beta, similar, 1/2 cosine of alpha plus beta plus 1/2 cosine of alpha minus beta. And there's some slight variations on this one right here. Some people write this as 1/2 parentheses and then the sum. And sometimes you'll see it written as a fraction with the sum over 2. But it doesn't matter whether you distribute the 1/2 or multiply 1/2 or divide by 2, it's all the same thing. But you will see some variation in these formulas and the way they're written. That was close there. So it's kind of cool that this product turns into basically an average of two sine functions. Just kind of a neat way of looking at it there. And then the last, and this is all just in section 7.2, there's a whole nother set of formulas in 7.3, the sum to product formulas. And I guess I will squeeze them in here. So I didn't label these, did I? These are product to sum. Now, interesting thing about the product to sum, notice there's 3 of them. And some people ask, well, if there's a sine cosine, why isn't there a cosine sine? And you just switch alpha and beta and you get the same formula really. So there doesn't need to be a cosine sine. It's the same as the sine cosine. So sometimes when we switch things, it doesn't matter. Sometimes it does. There it does not. All right, so combinations for a sum to product. We could have a sine. Here we're going to use u and v plus another sine. One option. We could have a sine minus a sine. We could have a cosine plus a cosine. And we could have a cosine minus a cosine. So there are 4 possibilities there. And then the formulas are twice, and this is going to turn into a product, sine of u plus v over 2 times the cosine of u plus v over 2. And I don't expect you to memorize all of these, but I do expect you to look at a situation and then match the situation with one of these, which is what we're going to try and do today. There are 2 I think you should memorize here, and I'll highlight those in a sec. This one is the sine of u minus v over 2 times the cosine of u plus v over 2. And the over 2 is inside of the sine function. Order of operations matters. This one is cosine u plus v over 2. Oops, I missed my 2 out front. and then cosine u minus v over 2. And last, this one is twice, and this one is a negative sine of u plus v. Let's try that v again. Over 2 sine of u minus v over 2. All right, so those are all of the formulas in section 7.2. 7.3 is going to have another page, and I said I would highlight the important ones. I think the most important ones are the angle difference formulas. So the cosine of alpha minus beta and the sine of alpha minus beta. And in particular, the cosine is the most important one. Almost all of the other identities on this page and in the next section all come from the cosine of alpha minus beta.